Hi, this is the first lecture of signal system. First, we like to talk about the LTI system. LTI system actually stands for linear time invariant systems. So to begin with, we like to talk about why it is such a good deal to talk about LTI system. Now, to start with, let's look about this. Now, this is a all possible system. What we mean, all possible single input and single output systems. And we like to restrict ourselves on this particular subsystem mathematically. This is the LTI system, the linear time invariant system. Why it is such a good deal that we need to spend so much time to talk about that? First, let's talk about in real most of the cases, probably the system is nonlinear system or time variant system. We just like to use the LTI system to approximate this particular system. Once when we have approximated the system, then we will be able to do control and signal processing analysis on this particular linear, nonlinear, or time invariant systems. Because the linear LTI system is such a good way that we can use mathematical ways to start with. There are so many advantages. So we are going to figure out what are the advantages of the LTI system then. Now, suppose we have a LTI system here. Then usually we like to find the system output for whatever given system input. Then what do we need to know? We just need to find the impulse response first. Impulse response. I will talk about the impulse response later on here. Then the impulse response usually is written as h of t. Okay, and how the output is done is by the process of convolution. Okay, the convolution is, so for the system output, yt is equal to xt, the input. Such a symbol is called asterisk. The system h of t, the impulse response. Then this asterisk is actually called the convolving during the convolution. Right. So how it is done is graphically. For the system input x of t in such a graphical way, then the output is y of t, and this is h of t, and h of t actually relates x of t to y of t. We call it the impulse response. That means when the given input x of t is a delta function x of t, then the output will be h of t. So input, impulse, output is a kind of impulse response h of t. That is the impulse response. And we will talk about the detailed operation of the convolution in later of our course. Now, the good thing is we do not need to know about all the details about the system. We only need to know about the h of t, the impulse response. Once when we know the impulse response, then we can find the output of the system for whatever input of the x of t. Now another way to do it is by the transfer function. transfer function. Right, transfer function is written as h of s. S, that means in the Laplace domain. Right. Then the good thing is, right, the output y of s, it will be equal to x of s times the transfer function h of s. Right. So in the Laplace domain, the good thing is we do not need to do the complicated calculation on the convolution things, right? But this one is being carried out by the Laplace transform. Now, another thing that the last thing is we can do it from the frequency response. Right, the frequency response. The frequency response is hj omega. We know that j squared is equal to -1. Omega is the angular velocity. Right, so the j omega given us is j omega in the frequency response is equal to xj omega times the hj omega. In fact, the hj omega and x of s is very closely related. In most of the cases, we can simply just substitute s by j omega. They are the same, and we'll work on this frequency response later on. And how we are going to do that, we just obtain this from the Fourier transform. Right. Then, from what we have seen, that we can simply see that these three, the impulse response in the time domain, and the transfer function in the s domain, and the frequency domain should be quite closely related. In fact, they are. The transfer function here, h of s, is simply equal to Laplace transform of h of t. And
this majesty here.
The frequency domain here is equal to the Fourier transform of h of t. So these sum up the three major things that we are going to do later in the courses. Now, the interesting thing is whether we are going to work on the impulse response, or from the transfer function, or from the frequency response. We just need to know one thing, is the impulse response. The impulse response enable us to find the h of s, and also enable us to find the hj of omega. For the control people, which they usually like to work from the transfer function h of s using the Laplace transform. For the communication people, we like to work from the frequency response hj of omega. And all of these we will cover in detail in later of our course.